Hi, my name is Pratibha and welcome to my talk on scaling Django app with MySQL. MySQL has been criticized for being hard to scale and sometimes that is true. But usually you can make MySQL scale well if you choose the right infrastructure and architecture and implement it very well. We can build Django applications with MySQL that can grow very large while remaining fast, efficient, and economical. So, just to be clear, this talk is not about MySQL versus Postgres. We will totally focus on how to use MySQL to support high availability. Let's see the outlines. We will be discussing why we should scale. Is it going to be cost effective? The scaling options that MySQL provide, Django settings that can enhance the connectivity with MySQL, the query optimization that should be taken care in Django, and finally, we will discuss the takeaway with this talk. So why should we scale? It's a big question that everybody asks. Scaling a database can become necessary for a variety of reasons. So you have created an amazing project with Django and a single instance of MySQL database. You want everybody to use it. Now, just because it's awesome and easy to use, right? With amazing projects come amazing loads of users. And with high loads of user, you get high web traffic. So the first reason why you should scale is to support high web traffic, to support high volume of users and data. And as your data grow, your number of users grow, your storage grow, your database size grow. So you have to make sure that you are in line with the requirement that is rising multiple bounds with every new user getting added. Also, as user grows, you will start noticing that your website is responding slow. You're facing performance issue. So we scale for better performance of existing users to improve system availability and geographic dispersion. In simple words, scaling is done to make your database handle more traffic or load for read and write queries. In the nutshell, we scale for better user experience. Is it cost effective? Well, there are always things that you have to consider. Of course, all the benefits of scaling a database comes at a cost. Some of the costs to consider include cost of hardware. It goes without saying that upgrading existing server or adding the new ones to a system will incur hardware or hosting cost. And of course, you have to make sure that you are accounting for deployment efforts, whether the time spent by in-house developer or the cost of external contractors you are going to hire. You have to consider the effort to install, configure, maintain the network and the hardware. In some cases, application code changes might even be required. Then, of course, maintenance. As the system become more complex, the maintenance costs grow by multiple rounds in documentation, training, backup, deploying, application enhancement, etc. But of course, if this cost is not a problem for you, you can always go for scaling. Now let's say, what are the options we have in scaling? Options for scaling a database can be grouped into two major categories. One is vertical. Scaling vertically generally describes adding capacity to the existing database instance without increasing the number of servers or database instances. Or horizontal scaling, which means, on the other hand, it leads you to referring an alternative approach of adding more server and database instances. Now let's see if they are really useful to us. When it comes to scaling vertically, it means that we are going to add CPU and RAM, and it is the easiest way to increase the capacity of your MySQL database. In vertical scaling, as we increase CPU, RAM, and storage, or buy more robust server in order to support more traffic, there is always a positive thing that can be led, and that is it will lead to less power consumption that comes from running multiple servers, or cooling cost, or generally less challenges to implement. Of course, less licensing cost. But the problem with this approach is the cost that will incur by increasing the hardware. It's always more costly. And then there is always a limit on number of things you can add into your hardware. I mean, there is always a limit in which you can increase the CPU or the RAM. So there's a hardware limitation. Then, of course, there is a greater risk of hardware failure. If one instance go down, that's all, your whole database is gone. Then why should we go with vertical scaling? Because it is easy. So if you only want to increase your capacity by a certain factor and it is not going to be a problem in terms of hardware, always go with the vertical one, because it makes sure that you don't have multiple servers to support or maintain. Then if you're going to support multiple servers, or let's say you have a project with a requirement of high availability or failover, or additional server will be the best solution. Horizontal scaling can be your go-to option because it is much cheaper than scaling vertically. It is easier for fault tolerance. If one server go down, you always have the other servers. And it is easy to upgrade. You can always go with a new instance and add that node. But it has its own side effects because it will have bigger footprint on data center given the number of nodes you are going to have. Obviously, the utility cost will increase with each server. And if you're going to use the paid databases, there are going to be the licensing fees. Now, there are multiple ways you can do the horizontal scaling. The simplest one is active passive. This is the old-fashioned approach with two database instances. One is active instance and other is passive. All queries, read and writes are directed to active instances. Write operations are applied to passive instance to keep it in synchronization. In the event of failure of active instance, query and update traffic is redirected to passive instance. Now, this is the easiest way to handle the failover and have high availability. Now, the positive thing about it, it improves your availability and failover, but it doesn't improve the capacity and performance because it's always a single instance you are connecting to at a time. The other option that we have is master slave. Now, master slave looks very fancy because you are using two or more database instances. One instance is always master, other all are slaves. All writes will go to master and all the read operation goes through slave. This helps in balancing the read and write operation, and because different servers are involved in making sure that the read and write operation load is not ending up on single instance. In the event of failover of master, one of the slave instance will become new master and update operations reroute. Generally, we tend to create master-slave architecture and route all the write queries to master instance. And of course, when we are reading from slave, it is much easier and faster. There is a specific problem with this master-slave approach that we have noticed when we were working with a record. So suppose every record that is inserted in MySQL table have one primary key to index the record for faster select operation. Generally, we have MySQL insert ID as our primary key. But what happens that when we have multiple masters, this key can be duplicated across databases. Now, that is what we don't want. There are multiple solutions to it, like you can have your own ID generator, or you can ensure the concurrency in database. But of course, you have to make sure that you are in align with all the issues that comes with master slave. Now, if we look in the nutshell, the master slave have one master, unlimited slaves. It is great for application which have high read operations. It is good for addressing the I/O bottlenecks like network or the disk I/Os. And especially for geographical dispersion, you can have if your content is image or video, you can have content distributed network, and they will all the read operations will get rerouted to them. But it require application logic to separate your read and write operations, which is an add-on in the con side. And then replication is asynchronous, so instances are not may not be in synchronous, may not know what is written on the master at any given time. And master instance can be scaled vertically, so it is helpful in making sure that it's like a combination of it's a combination of vertical and horizontal if you want to scale the master vertically. It's always helpful to go with master slave, especially when you know that your read operations are high. Then the next approach can be cluster. I think cluster is the most widely used approach when it comes to scaling. It got first introduced in MySQL 5. And the cluster distribute query processing and data storage access across multiple nodes to eliminate single point of failure and allow almost unlimited scaling. The cluster is made up of three types of node: storage nodes, SQL nodes, and management nodes. To realize the full high availability potential, a cluster should contain at least two of each types of nodes for the failover, of course. So the image that is shown here is a typical setup of cluster setup in SQL. Now, if we look at the pros and cons of cluster, I would say that it's a good solution for high availability. Then we have in-memory storage providing the high performance. It is good for scaling applications which are heavy in write. Suppose you have a database, or you are writing a Django applications which is supporting the backend of some backend of an IoT device, and the firmware or the device itself is sending you data, so you have to frequently write it, but the read operation is less. That means at the UI side, user is not reading it that much. So of course you have to make sure that it is aligned with the requirement, and the write heavy is making sure that your all data is written in database. So this is one of the things that you need. And you can scale the specific portion for cluster, of course. Now, synchronous replication between nodes make cluster inappropriate for geographical dispersion. I have read the whole line because it makes sense more when somebody reads it, believe me. So what happens that when your nodes are geographically located in different parts, synchronization or replication can be a problem when it comes to cluster. There can be the network problem, there can be many things that denotes in the environment, that contributes in the environment that is doing the replication. So you have to make sure that you have dedicated lines for that. Now, if you want to host an environment with storage area network, please don't go with cluster, because it is going to create lots of problem in writing into storage area network. Of course, it is difficult, it is highly complex to maintain a cluster. Not with the new, I would say that if you're going with the latest cluster manager of MySQL, you may find it comparatively easier. But if you want to use the cluster with its uttermost, uttermost, whatever they are providing with everything, it is more complex. Then comes sharding. Sharding is a very interesting concept in my opinion. Sharding comes in many forms. In the most basic sense, it describes breaking up large database into many smaller databases. Sharding can involve strategy like carving off tables or cutting up tables vertically by columns. And I'm referring to the strategy of horizontal partitioning, dividing the large tables by rows. This is relatively complex configuration and generally used by the most demanding applications. In my opinion, consider sharding only as the last option of scaling. Before going down to the sharding path, I would suggest that see if you can use the other three options or the combinations or the permutation of other three options, because sharding you have to be very careful when you are splitting your data vertically or horizontally. If sharding looks like the best option that for your application, good thing is that there are several sharding solutions have emerged, so you don't have to worry about making out or creating something your own. Now, if we take an overlook of sharding, it's like good strategy for handling extreme database loads. It's easiest and most appropriate when you have few tables but lot of joint operations, and shards are not required across them. Now, success depends largely on sharding strategy and sharding size. Suppose you are splitting the table vertically, and it is still your data is still growing by leaps and bounds. It doesn't make sense. Your database size and is still increasing, and it will cause problem in gathering that data in longer run. Of course, it will need you to resize your shards every now and then. So yes, that is one of the disadvantage it has. It is the highest. It has the highest complexity among all the other options we have. But it does improve availability. Impact of any shard failure is very small because you will lose only a portion of data if you lose one of the shards. Now, but why scale horizontally? Of course, for the project with requirement of high availability of failover, it always makes sense to add additional server because it will make it more available. If one of the server goes down, you have the new one. It's always easier, it's always approachable. Now, MySQL is the world's most popular open source database, and Django is famously known as web framework for perfectionists with deadlines. So when we have both of them together, of course, we should have something which is highly available and working as a perfectionist on its own. So whenever we are deploying an infrastructure, the bottleneck is not always your database. It can be your load balancer. It can be your Nginx. Maybe your Nginx is not accepting as many requests as it should. So you may have to increase the Nginx workers. GUnicorn workers. Maybe you can have more workers in parallel that can serve according to your hardware configuration. Of course, Redis, always go for the caching. It's always advisable to use caching when you are doing in Django. Then, of course, your database that we are discussing right now. We have to make sure that our database is performing as it should. Here, I have noted down some of the settings in Django that we should take care of so that our application doesn't doesn't have the problem of high availability connection. Connection message none, of course. The storage engine we are redefining. We are isolating the transaction level to read commit so that we will know that every time there's something to read, it is always followed by a commit. So all these things, all these settings are always useful to make sure that the setting your SQL mode and isolation, make sure that your data is what is available highly to the end user. Now, when it comes to Django query optimization, I'm going to scoot through a bit faster because Django is highly known and many people who are using Django knows these settings very well. But in case you have skipped them, let's go through them just to revise ourselves. Like if you don't need your data rows and you just want to count them or know if they exist or not, use count or exist or values if you have specific column to be retrieved. Don't go with all of them. Like if you just use count, your size or the data will reduce, it will just return you the count. Let database do whatever can be done in the database itself, the joins, the filters, everything. Make sure you're making database do the work that you're trying to do at the Django level. Use foreign keys directly. This has been a very useful thing for me, because every time I want to get a data and I just want to return its ID of the foreign key, I have to go to the table and get the ID. But this is something which improved my query by 20%, because I was directly using the key in it. Or use annotate to do aggregation, or filter or exclude. Just remove the things from the rows or the query that you are executing. Don't fetch the data that you don't need. It is going to improve your performance highly. Specifically, use filters, because when you are using filter, you're making sure that database is returning only the rows which have all the details, and exclude. We unknowingly fetch the date timestamps which we don't need. If you want the individual use objects, just use Unix. It is and indexed it through columns. It's one hand tool. It's like a Swiss knife for us. Then if you want to have a row which have multiple foreign keys, use select related or prefetch related. It will get you the data beforehand, so you don't have to go back to database and get the data of the foreign key again. And don't order the result if you don't need it, because it is by default order with no parameter. So if you don't want it, just don't order it. Doesn't make sense. Caching, in the end, caching is going to make sure that your life is easier and your APIs are responding quickly enough. Because if you have a static data that you keeps on getting, if you have a data that you keeps on getting, retrieving and showing, and it is not going to change over time, make sure that you are using caching. Caching is going to make your life much easier. Now in caching, you can have query caching, template caching, asynchronous code. In query caching, of course, you have a query, you know that that data is not going to change over time or at least, let's say, for next 5 minutes. Just cache it in memcache, dump it over there. It's going to save your database go back and forth time a lot. Template caching, if you know that certain files are always going to be linked in this template, and every time you don't have to render your template and then send it. Render it once, save it, and send it later. It is going to make sure that your template is same as it is supposed to be, but still it is coming from cache. And then there will be instances when your synchronous API calls are blocked by non-synchronous work. We recommend using RabbitMQ and Celery to handle asynchronous work. Once you get used to them, they're very handy. In conclusion, is MySQL is the best database for Django? Well, there is no right or wrong database. It purely depends upon the requirement. If your usage is basic and you're not going to use database triggers and notification systems, you can use MySQL instead of Postgres. But if you have a fancy thing, like you're going to use the MQTT and you want to send data there, or you want to have triggers, then you have to look for the alternate option. But it also depends upon where do you see your project in next 5 to 10 years. Now, every project has its own unique requirement and characteristics that will shape the selection of appropriate scaling option. Here are some things to think about before selecting a scaling strategy for your application database. What is the anticipated data load? It is going to be high or less or medium? Or what are the requirements of availability? Can you have a downtime? What about the performance? Is it okay to be slow? Because there can be the queries in which you can just send the data and the UI doesn't wait for the response, and you can send the data in the callback API. What are the requirement of failover and recoverability? Is it required that it should be complete 100% failover? Then what is the ratio of write and read operation? Is it write heavy? Should we go with cluster, or should we go? Is it okay to have an active passive in the single instance? Is your user geographically located in different regions? Do you need geographic dispersion? Does the database create higher than normal proceeding loads? Does it have stored procedures that keeps on calculating things every now and then so that you can have the data or the final result beforehand? If it is an upgrade, or if there is an upgrade for the existing system, what is the utilization of existing hardware? How much RAM and CPU are you using? Where is the bottleneck? Why there is the bottleneck? There are innumerous questions which you have to consider before going for scaling. I hope this checklist helped you. These are the useful links that helped me when I was working or the scaling my MySQL database app, which I was using for my Django application. So I hope they will be useful for you too. Thank you. Happy coding.